Let's now explore exponential and logarithmic graphs. Starting with exponential, the general form for these graphs are y equals b to the power of x. And you'll notice here b represents numbers, whether it's 2, 4, whatever. X is the x, but it's now the exponent. Okay, the variable's up as an exponent, making these exponential graphs. The one we're going to explore to begin with will be y equals 2 to the power of x. And again, we don't know how to graph it yet, so we're going to use our tried and true xy table, plug in some numbers. So we're going to take x values such as 0, 1, 2, and 3, plug them in, and get y values out. So we're going to plug it in for x here. So maybe have your calculator handy. 2 to the 0 power, anything to the 0 power is 1. 2 to the 1 power is 2. 2 to the 2 power, 2 squared is 4. And 2 to the 3rd power is 8. 2 times 2 times 2 is 8. Okay? And the more we plug in, say we use 4, 2 to the 4th power is 16. These numbers are growing very, very fast. If we plugged in 5, 2 to the 5th power would be 32. These numbers get very big very fast. They grow exponentially quick. So let's graph what we have so far. So x value is 1, 2, 3, 4. And I'm going to leave the y-axis alone for right now, just because these numbers are going to get very big very fast. Let's see. Well, actually, I'll put some 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. So that was 16. This was 1, 2, 8 right there. All right, let's put some points on this. So my first point is 0, 1. So 0 over 1 up. Next point, 1 over 2 up. 3 over 8 up. 4 over... What'd I do? Whoops, I missed one. Sorry, 2 over 4 up. 3 over 8 up. 4 over 16 up. And you notice this isn't a straight line. What we're creating here is a bit of a curve. Okay, so starting here, this is going to curve upwards. Now after this is the question. If I plugged in 5, it would be 32. If I plugged in 6, 2 to the 6th power is 64. 2 to the 10th power, 1024. These numbers go very, very fast. This is going very fast upwards, but it is still growing up. The bigger the number we plug in, the bigger it grows very, very fast. Now the interesting part is what happens on the other side. So if I plug in other numbers, like negative numbers, going the other direction, negative 1, negative 2, negative 3, you might need your calculator to plug these in. So we're looking for 2 to the negative 1 power, 2 to the negative 2, or 2 to the negative 3. What are those values going to be? So plugging those into the calculator, 2 to the power of negative 1 is 0.5. 2 to the negative 2 is 0.25. 2 to the negative 3 is 0.125. So my numbers are getting smaller and smaller, getting closer and closer to 0, it looks like, as we plug these in. So you put some lines over here. So negative 1, negative 2, negative 3. These numbers are getting closer and closer to 0. So 0.5, 0.25, 1.25. But it's actually never going to get to 0. The bigger numbers we plug in, say like 2 to the power of negative 6, 0.0156. These numbers are getting smaller, but never getting close enough to 0 to actually touch it. So we're getting closer and closer, and that was kind of sloppy there. I'm going to show this a little bit better. There we go. Okay, so it's getting close, but the more you zoom it in, so actually if we zoomed in, it would never really cross or touch if we drew this correctly. Okay, so what we want to talk about is what that means. So I'm going to highlight this x-axis here because it's getting closer and closer and closer to 0, but it's never going to cross it, it's never going to touch it. And the word for that pink dotted line that I've drawn is an asymptote. You can't touch or cross asymptotes. That's the asymptote line. So we'll write the little definition down here. An asymptote is a line that continually approaches a graph but does not touch it. It gets closer and closer and closer. You can zoom in more and more and more, and there'll always be space between that graph and that line. Now, this blue line will continue, the blue graph will continue going to the left, just gets closer and closer until we almost can't see it with our eyes anymore. All right. Now, what we've drawn right here is a exponential graph, and more specifically, this is exponential growth. As it goes from left to right, the graph grows upwards. The opposite of that would be exponential decay. So a quick little graph of that. That means something's going to start up high and then go downwards. Okay, it's going to get closer and closer to zero towards the right. So something like this would be called exponential decay, where it has a lot of value and then it goes downwards. Now, if we're thinking about real life examples here, exponential growth kind of would be like maybe some sort of virus, whether computer or physical. The sickness gets spread to somebody and then it grows faster and faster as it approaches bigger numbers. Okay? The more people you come in contact with, the faster this stuff grows. Starts off slow, grows fast. Exponential decay, probably get into physics or something like that. That's when we're talking about maybe half-lives and other things growing smaller. Okay? So, on the other hand, something else I want to talk about are the log graphs. Okay? Logarithmic graphs are very similar to exponential. The only thing that's going to change is that, I'm going to make that note over here, logarithmic graphs are going to have vertical asymptotes. Whereas we see here exponential graphs have these horizontal lines that they never touch across. Log graphs have vertical asymptotes that they'll never touch across. So the graphs would actually curve very similarly, but now go off like this, get really close to that y-axis, but never touch across it. So these ones have what we know as vertical asymptotes. These ones are horizontal asymptotes. Okay, sorry I had to scrunch that up. We have a first example coming up here. So what we're going to look at is the graph is already going to be made for us. We want to analyze it. All right, we're going to analyze these, talking about domain, range, and identifying the asymptotes. So first thing we want to find out what type of graph it is, whether it's exponential or logarithmic. The easiest way to tell is to look at its asymptotes. If it has a horizontal asymptote, okay, so if there's a line or horizontal line that it looks like it's approaching, it's going to be an exponential. So it looks like, you see how that line flattens out eventually at this number here, which is 1. That is a horizontal asymptote. I'll label that as HA. So this one right here that we found is exponential, and from left to right it's going upward, so this is an exponential growth graph. We can see that it does have some intercepts. Right here, this does cross the y-axis, so that is a y-intercept. So let's write that point. The y-intercept is 0, 2. The horizontal asymptote, we can go ahead and write that out. Horizontal, now remember, horizontal lines are going to be y equals. If it's a vertical asymptote, it's an x equals. But for horizontal asymptote, the line is y equals 1. It's getting really, really close to 1. It looks like it touches, but if we were able to zoom that in forever, we would see that there's still space, because remember, this goes off in either direction. Let's talk about domain and range now. Domain and range. Alright, remember, domain is measuring side to side, range is up and down. Does this graph ever stop going to the left? No. The number off to the left is negative infinity. And infinities get parentheses. Does it ever stop going off to the right? No. It's very slow, but it's still going to the right, still going this way. It just gets a little bit slower. It goes up really fast, but it's growing to the right, kind of slowly. So positive infinity over there. Range. Now we got to measure the y values, the up and down. Does it ever stop going down? Now we got to be careful here. It does stop going down. It gets really, really close to a number. It's not actually stopping, but it's getting closer to that number, and that number is 1. Does it ever get to 1? No. So since it doesn't get to 1, we can't include it, so we have to give this a parenthesis. That means it's getting closer and closer and closer to 1, but never touches it. Now, does it ever stop going up? No. It keeps going up forever, and that one's easy to tell, and the number up that way is positive infinity. So we've identified what it is, the intercepts, the asymptotes, the domain and range. And you notice there's no x-intercept on this because right here, this line, this 1, is keeping it from crossing, so it can't get to the x-axis, so there are no x-intercepts. All right, let's take a look at another graph. All right, so our next example here. Again, is it exponential? Is it logarithmic? Let's look at the asymptotes. Now I look around. It looks like it's approaching this line right here, this line -2. All right, so that's a flat line, that's a horizontal asymptote. So we have a horizontal asymptote at y equals -2. And if it's horizontal, now we know that this is exponential and it's going upwards from left to right, so this is growth. Does it have intercepts? Let's see. That right there is an intercept. That is the y-intercept. That y-intercept is at 0, -1. This time it also has x-intercepts because you see it does cross the x-axis. It's not a great number to read. We can make an estimate of that. X-intercept. And let's call that 0.9-ish or 0.8-ish, whatever you want to call it, by 0. Side to side, no up and down. Let's also analyze the domain and range. Domain. Does it ever stop going left? No. Does it ever stop going right? Slowly it goes that way, but it still keeps going. So the domain, negative infinity to positive infinity, small number first, big number second. Range. What stops it from going down? It gets closer and closer to that -2, but it doesn't touch it, so we give it a parenthesis. And it never stops going up, so give that a positive infinity up there. All right, so let's take a look at a couple more of these. Again, this graph is approaching a line, a horizontal asymptote, and it's going to be right here. See, it's getting close. Over here, it's going to continue off that way and keep going that way. So since it approaches a horizontal asymptote, it is an exponential graph. This time it starts up high and then goes low. This is exponential decay. With a horizontal asymptote at y equals, this time it's at +2. Does it have a y-intercept? Yeah, it crosses the y-axis right here at 0,3. It never gets back down to the x-axis. This is your x-axis down here. Can't get to it because it won't cross the asymptote. So if you really want to write it, x-intercept, there is none, or put NA. And again, let's do domain and range. Domain never stops going left, never stops going right. Range, lowest it goes down to, it approaches the 2, doesn't touch it, so we give it a parentheses, and it never stops going up, and the up number on the y-axis is positive infinity. Alright, so the more we go through these, the better we get at them. Alright, let's take a look at this one. Now this one looks a little bit different. First thing you want to identify is kind of where the asymptotes are. Is there a line side to side that this is approaching? No, this looks like it keeps going up nice and slow. This one keeps going down, but you see how it's getting really close to this? Almost to the fact that it looks like it's touching? This one is a vertical asymptote. Okay, that's a vertical line asymptote. And we found out if it's a vertical line asymptote, this is going to be a log graph. This is a logarithmic graph. It's approaching a vertical asymptote. And specifically, that vertical asymptote is happening at, now if it's vertical, it has to be x equals, and that number is at 0 here. Okay, the vertical line's at 0 on the x-axis. X equals 0. As for intercepts, here's an intercept. That one's actually an x-intercept. That point is at 1, 0. It looks like it gets to the y-axis, but actually the y-axis is the asymptote, so it doesn't touch it, doesn't cross it, so there is no y-intercept. But we can do domain and range. Now don't get lazy, these aren't going to be the same as before. Domain. Domain, remember, side to side. Does it ever stop going to the left? And in fact, there is something stopping it from going left. That vertical asymptote at 0. But it doesn't touch it, so we give it a parentheses. And does it ever stop going right? No, it doesn't. So positive infinity. As for range, it never stops going down. You see the arrow pointing down and the arrow slowly going up. Never stops going down, never stops going up. There's domain and range. Alright, one last problem here. Again, we see that this graph is approaching a vertical asymptote. It's getting close to this. It actually kind of disappears, but it will continue going downwards. It won't go to the left anymore because of that vertical asymptote, meaning that this is a log graph. That vertical asymptote itself is at x equals -3. There is multiple intercepts this time. We have an intercept right here. That's an x-intercept happening at -2, 0. And in fact, there is another y-intercept because it does cross the y-axis this time at 0, 1. Domain and range. Last thing we're going to fill out. Domain, it does stop going to the left. The number that's stopping it is -3. It doesn't touch -3, so we give it parentheses. But it does continue off to the right at positive infinity. As for range up and down, it never stops going down. It never stops going up. So the easy way to tell these apart, and I'll scroll back up to the top. Exponentials. So this is our exponential here. These have horizontal asymptotes. Okay, exponentials have horizontal asymptotes. Logarithmics have vertical asymptotes. That's the way to tell them apart.